The last aspect of production-grade ACP that we want to cover is observability. Observability is the ability to understand the internal state of a system by examining its external outputs, such as logs, metrics, and traces. If you are familiar with the microservices-based architecture, you probably are already familiar with this concept. In observability, logs refers to the details of events such as errors and exceptions in code or responses from external APIs. A metric is a numeric measurement that represents the performance or behavior of a system over time, typically collected at a regular interval. For example, number of agent runs is a metric. Trace provides visibility on how requests flow between agents. In a multi-agent workflow, multiple agents are engaged and they often talk to each other, and if there is an error somewhere, it will be hard to understand where the request is failing, and traces will give us visibility as to what agents are engaged or communicated with to fulfill a request. Why observability matters in ACP and agentic AI? As I said, debugging multi-agent systems with distributed agents is tricky, especially with synchronous workflows, multiple services, and custom logics. Observability offers a powerful way to trace and understand these systems in real time. By instrumenting both the ACP communication and agentic logic which you write in your ACP agent, you gain visibility into how data flows, how decisions are made, and where the bottlenecks or errors might occur. ACP and ACP SDK integrate with OpenTelemetry standard to capture signals, including metrics, logs, and traces. So we already said that OpenTelemetry is the foundation of observability in ACP. OpenTelemetry follows a specific path to capture the metrics and visualize them. So you have your ACP agent, that is where the signals are initiated. For example, metrics and logs are created. Then the generated signals are sent to OpenTelemetry collector. And from OpenTelemetry collectors, these signals are exported into some sort of backend system. There are different backend systems for different types of signals. For example, Prometheus is a backend for metrics. Grafana Tempo, for example, is a backend for traces, or Jagger is a backend for traces. Then if you want to visualize these signals, you will need a UI. For example, Grafana is a good UI to visualize the signals, or New Relic has a UI to visualize them. Now let's see some of the options that we have for OpenTelemetry collector. For OpenTelemetry collectors, you can use Grafana Alloy, for example. You can use the standard OpenTelemetry collector, which is general purpose and open source. If you prefer a SaaS solution, you can use New Relic, or you can use Jagger. Jagger is only used for traces, not for metrics and logs. For backends, you can use New Relic or Prometheus for the metrics, or you can use New Relic and Grafana Loki for the logs. For traces, you have more options. You can use Jagger, which is open source and is very simple. You can use Grafana Tempo, or you can use Arise Phoenix, which is purpose-built for tracing large language models. Now, to visualize the signals, you can use Jagger for traces only. You can use Grafana for metrics, logs, and traces, or you can use New Relic, or you can use Arise Phoenix. The reason that I suggest Grafana or New Relic is that most companies already have an observability system in place. If you work for a large corporation, you probably use something like Splunk. But most other companies use Grafana or New Relic. Grafana is a full set of observability that has components for logs, metrics, traces, and it does both collection and visualization. And as I said, if you prefer a SaaS solution, you can use New Relic, which offers the same services. So these are the options and you can explore them. In this course, I'm not going to show you how you install Grafana, for example. That is a very large topic. I have a course about Grafana and its components, and that course is about 10 hours long. And also I have another course about New Relic, and that course is also about like 5 or 6 hours long. So unfortunately, I cannot include that into this course. However, I will show you that how we can use them. So how do we instrument our agents? Instrumentation means that we start generating and sending the logs, metrics, and traces to OpenTelemetry collector. ACP SDK has already have integration with OpenTelemetry. However, by default, this integration is disabled. To enable this integration, when you do server.run in your server's code, you pass a parameter to it. The parameter is called configure telemetry and you just set it to true. Once you do that, ACP SDK automatically starts capturing traces and the response HTTP attributes such as user agent, response code, and so forth, and also any fast API related attributes such as route and path info. As you already know, ACP SDK is built on top of Fast API, so all your knowledge about instrumenting Fast API also applies here. On top of the standard metrics that are captured, you can also create your own signals, including metrics and logs, and send them to an OpenTelemetry collector. Okay, let's go and see this in action. For this course, you will need Docker Desktop to be running on your machine. To install Docker Desktop, simply open the browser and go to docker.com and download Docker Desktop on your machine. Make sure that after downloading and installing Docker Desktop, you restart your computer. Otherwise, you will get strange errors and it will make you very frustrated. Before we work with Docker, let me also show you the Arise Phoenix. This is the open source LLM tracing solution. If you are interested, you can have a look. It's quite new and sophisticated. It is not free. However, I think it's worth learning this as well. So let's get rid of this. Now let's go to Visual Studio. Now I'm in Visual Studio. Again, if you clone the GitHub repository of this course, you will see that there is a directory called Observability. There is a text file in that directory called docker.txt. And it gives you a docker run command that brings up Jagger. If you copy this and go to terminal or go to command prompt and paste this command here, it will bring up Jagger. Now if we go to Docker Desktop, this is Docker Desktop, we will see that a container has appeared here. The top port number, that is 16686, is the port of Jagger. If you click on it, it opens Jagger. Now let's go back to Visual Studio. In Visual Studio, under directory of Observability, there is a server. This is a copy of this server.py, however, it has instrumentation. And to do the instrumentation, all I have done for now is that I have set configure telemetry to true in server run. Now let's run this server. So server is listening. I also have a client.py, which is basically the same client that we had before. And I just run the client to send one request here, and I will run it to send the second request. Now let's go back to Jagger. In Jagger, if I refresh, and then I open services, you will see that ACP server appears here. That is the default service name. And if I click on find traces, you will see that I run the client twice and you see two dots in here. That basically represents two runs that we had. Now we only have one agent, so you don't see a connection between these dots. But if you have multiple agents calling each other, you will see a complete trace of how they work together. As I said, Jagger is very simple to run and look at. However, it only supports traces. So this is a simple example. Now, if you want something more sophisticated, there is a GitHub repository that belongs to my Grafana course, and it is grafana-udemy. If you clone this repository, there is a folder or directory called Docker. If you have a Mac or a Linux machine, you can use this. It doesn't unfortunately work on Windows. If you clone this repository and go to Docker folder in terminal and simply execute docker-compose.sh, it will give you a full stack of Grafana stack, including Grafana, Grafana Alloy, which is OpenTelemetry collector, Grafana Loki for logs, Grafana Tempo for traces, and Prometheus for metrics. Make sure that you do not run a Docker Compose command with this Docker Compose YAML file. It will not work. You have to run this docker-compose.sh script. I have executed this script. So let's go to Docker Desktop. In Docker Desktop, you will see that I have a stack called Docker. And it has so many components in it, like Tempo, Prometheus, Loki, Grafana, Mimir, and Alloy, and so forth. If you are not familiar with what Grafana is, don't worry about it. Just run the stack and I will show you how to use it. If you are interested to learn this, which is I think very good to know, you can also look at my other course. So Grafana Alloy, as I said, is the OpenTelemetry collector. OpenTelemetry collectors listen on these two ports, 4317 and 4318. 4317 is for gRPC protocol and 4318 is for HTTP protocol. Back to Visual Studio, let's stop the server. The server shows errors because I stopped Jagger. I run the server again and I run the client, say twice, for example, or 3 times. In Grafana, I don't need to open Alloy because it's only a collector. We can open Grafana. So this is Grafana. If I click on it, and I can also close Jagger, it opens Grafana for me. I can go to Explore and I can look at, for example, say Tempo. Tempo is for traces. And in the search for service name, I can see that there is a service called ACP server. And if I click on run, you can see traces are coming through. Every trace has multiple spans. You can also create your own span. And if I click on service graph, it shows that I, as the user, interact with this agent, ACP server. And also I may have other services running in this system, not relevant to our course, but you can see all the services in one page. So that is traces. For logs, we can open Loki, and to filter, we can say service name is ACP server, and you can see that all the logs are coming through. These are the logs. So what else? For the metrics, we should go to Mimir, this one, go to Builder, and we can say metric should be hotel, any metric that starts with hotel, and then this is a custom metric I created. We can see that metrics are also here. Now let's see where this metric comes from. If we go to the code of our server, we will see that we get some metrics and some traces and some logs as a standard. However, if you want, you can create your own metric and your logs as well. To create metrics, you can import the metrics class from OpenTelemetry library, then use metrics.getMetric to create a metric. After you get a metric, you should create some type of either counter or gauge or histogram. So I created a counter, and the counter name was hotel.meaningagent.runCount. It's basically this metric that you see here. And every time we execute the agent, I am basically adding 1 to this counter. And then the value of this counter is automatically captured and sent to OpenTelemetry collector. For custom logs, you can import getLogger and logRecord from OpenTelemetry.logs. This is not relevant to ACP agent. It is an OpenTelemetry thing. And then you just get a logger. Basically, you get an instance of logger, and then you do logger.emit. You can either emit a log record like this, or just emit a string and it will appear in your logging system.